Hi everyone, welcome back for day 2 of comparing functions. We're going to jump right in. This kind of picks up where we left off yesterday. So example 1 says, Noah just received his driver's license. He decides he is going to drive to California. As he drives, he calculates his speed in miles per hour as shown in the graph below. A, what is his average speed in miles per hour? Okay, so this kind of actually goes back to our first couple lessons when we were doing interpreting functions. So looking at the graph, I can see that it's a proportional relationship because it's a straight line that goes to the origin. And so this point right here, 155, is actually our unit rate, or our constant of proportionality, which also means it's our slope. So his average speed in miles per hour is 55 miles per hour. Write an equation to represent the graph. So since I already know the slope, the only other thing I need is the y-intercept, which because we've already said it's proportional, we know it goes to the origin, so the y-intercept is 0. And so the equation would just be y equals 55x. Part C, a y-ist also decides he is going to drive to California. If a y-ist drives at 66 miles per hour, who drives faster, Noah or a y-ist? Okay, so if a y-ist is driving 66 miles per hour, I know that that is faster than Noah, because Noah was only driving 55. So we can say a y-ist. Okay, so kind of an easy one to start with. For number 2, Julia and Cameron are opening their own flower shop. Julia charges an hourly fee as shown in the graph below. Cameron's hourly fee is represented in the table. So I'm going to go ahead and label this. Julia is the graph, and Cameron is the table. So first we need to write an equation to represent Cameron's hourly fee. Okay, so if I'm looking at Cameron's, which is the table, the first thing I'm going to look for is my slope. So if I were to do that, I would have to figure out if there is a constant change in y and change in x, because remember, slope is change in y over change in x. And if I were to do that, I'm just looking at the x column right away, and I'm seeing that it's going up by 3 and then up by 4. So really what I'm going to have to do here, since it's not constant, is I'm going to have to pick 2 points and find the slope between them. So again, to do that, we're going to use our slope formula. And I'm just going to pick the first 2 points. I'm going to use 526 and 841. All right, so my slope would be 41 minus 26 is my change in y, and 8 minus 5 is my change in x. All right, so this is going to give me 15 over 3, which is 5. So I know that my slope is 5. Now, to get my y-intercept, I'm going to have to use my slope-intercept form, y equals mx plus b, and I'm going to choose one of my points. I'm actually going to pick that 526, and I'm going to plug that into the equation for x and y, and I'm going to solve for b. So y is 26. My slope I just found was 5. The x-coordinate is 5, and I'm trying to figure out what b is. So 26 equals 25 plus b. To get b alone, I would subtract 25 from both sides. I'm going to rewrite this up here. Sorry, this is so crammed, you guys. And I'm going to get that b is equal to 1. Okay, so I'm going to write my final answer up here, I guess. Y equals, what do we get for the slope? 5x plus 1. Okay, so that's the equation that represents Cameron. Now let's go ahead and do part B, which is to write an equation that represents Julia. So we're looking at the graph for this. And so looking at that, I can see the graph is proportional, which is always great news because that 1/6 is our constant of proportionality, or in this case, our slope. So I don't have to do any work there. And again, since it's proportional, I know that b is 0. So to write my equation for Julia, it's just y equals 6x. So kind of nice. All right, who charges more per hour? So more per hour implies cost per hour, which is referring to the slope for these. And so looking at the equations, we can see that Cameron charges $5 per hour, and we can see that Julia charges $6 per hour. So who charges more? Julia. Part D, if they each completed 14 hours of work for you, how much would you pay each person? All right, so we're going to have Cameron versus Julia. So Cameron, we said, was 5x plus 1. Julia, we said, was 6x. And we're talking about 14 hours of work. And hours is x, so I'm putting in 14 in place of x. So I'm going to get that it's going to cost $71 for Cameron. And for Julia, 6 times 14 is $84. So that's how much you'd have to pay each person, given that those were their equations. All right, on to the back here. So for number 3, it says a chocolate shop charges per pound for various types of candy. The price per pound of the chocolate-covered pecans is shown in the graph. Chocolate-covered raisins are represented by the equation y equals 6.95x, and the price of the trail mix is shown in the table. Okay, so we have 3 different linear functions that we are comparing for this one. And so the first thing I'm going to do is they tell me the equation for raisins, so I'm just going to fill that in right here. Okay, and our goal, looking at part A, is to write an equation that represents each type of candy, the price per pound of each type of candy. Okay, so why don't we start with trail mix? Let's look at the table here. So just looking quickly at my X column, just because that's always the easiest, I can see that I'm increasing by 5 and then increasing by 4. So when that happens, this is where you want to use your slope formula to figure out your slope, because there isn't a constant rate of change that we can see. So I'm going to choose to use the first 2 points here, so 3, 2385 and 8, 6360. So I'll write that right here. Okay, so those are the 2 points that I'm choosing to use. And so I'm going to call that my first point and this my second point. So my change in y would be 6360 minus 2385 over 8 minus 3. All right, so if I subtract the top, I'm going to get 3975 over 5. And if I divide that, I get 795. Okay, so I have my slope for trail mix. Now I also need to figure out my y-intercept for trail mix. So I'm kind of running out of room here. I'm just going to keep going. So to figure out my y-intercept, remember I use my slope-intercept form and I pick 1 point. So I'm going to choose that first point and I'm going to plug that in for x and y. So y is 2385. My slope I just found was 795. The x-coordinate of that point is 3, and b is what I don't know. Okay, so 2385 equals 795 times 3 is actually 2385. And so to solve for b, I would subtract 2385 from both sides, and I would get that b is 0. Okay, so we did a lot of work there. So let's write this down. Trail mix. The equation for trail mix would be y equals, we got 795 for our slope, so 795x, and then you don't have to put the plus 0 because it's just not needed. And then raisins was next, and they gave us that. How nice. Y equals 695x. And pecans is our last one, so we're going to figure that out from the graph. All right, so if I go over here to the graph, wonderful. It is a proportional relationship. It's a straight line through the origin. So what I can do is I can pick out that 1, 9, that unit rate, which means that it's $9 per pound. And so sorry guys. So I know that my slope is 9. And then because it's proportional, I know my y-intercept is 0. So the equation for pecans is just y equals 9x. Okay. So for part B, which candy has the lowest rate of change and what does it represent? So out of the 3, we can see that raisins has the lowest rate of change because 695 is the smallest slope out of the 3. And what does it represent? Well, what does the slope represent in this problem? It's the y to the x. It's the cost per pound. So we want to say raisins, and then we want to say it is the cost or price per pound. Awesome. All right, very last one. If you bought 2 pounds of trail mix, 3 pounds of raisins, and 3 pounds of pecans, how much would you spend before tax? Okay, so it says lots of space here. Show your equation and substitution and make sure you answer the question. All right, so what I'm going to do is I'm going to kind of make a little, not really a chart, but some columns here. Trail mix, I meant to write trail mix, raisins, and pecans. Okay, so we said for trail mix it was $7.95 a pound. Y equals 795x. Raisins, they told us, was $6.95 a pound, and pecans we figured out were $9 per pound. All right, so it says right here we are buying 2 pounds of trail mix. So pounds is x, and so to figure out the cost, I'm going to take out the x and put in my 2 for trail mix. All right, so the total amount that I'm going to spend on the trail mix is $15.90. All right, then it says we're buying 3 pounds of raisins. So I take out the x in the raisins equation and replace it with 3 to give me a total cost for the raisins of $20.85. And lastly, I have pecans, and it says I'm buying 3 pounds of that. So 9 times 3 means it's going to be $27 for the pecans. So it says, how much would you spend before tax? Okay, so we're not caring about tax. We're just trying to figure out a total here. So we need to add the cost for the trail mix plus the cost for the raisins plus the cost for the pecans, to give me a grand total of $63.75. All right, great job, guys. You've officially learned all you need to know about linear functions. So we're going to spend some time doing some review in the next few days.